So we're now going to do maximizing area. The first thing I want you to do is take a look at all these formulas and make sure that you're familiar with them. This is everything that you should have learned in geometry class: area of a rectangle, area of a triangle, area and circumference of a circle. Remember, area has to be squared. So the area here is pi r squared. Circumference is 2 pi r. They both have a 2, but his is a power and his is a big number. And then if you do half the area, you just take that formula and cut it in half. Or if it's half of a circumference, then you would just cut it in half. We also have to make sure that we are very familiar with the quadrants. They go 1, 2, 3, and 4. Okay, those are the 4 quadrants right there. So what we're going to do is take a look at an equation on a piece of graph paper, and then we're going to be putting shapes in there. And then we're going to be maximizing the area so they have the most area as possible. Okay? All right, a rectangle has one corner in quadrant 1. So here's quadrant 1 on the graph. So this is a parabola facing down. Here it is. And there's one corner on this graph. I'm going to make sure that I put the corner right in the middle there, not looking like it's on an integer. Okay? Another one's on the origin. One is on the positive y-axis. So since this is going to be a rectangle, it's going to be right there on the y-axis. And one's on the positive x-axis. So here is the rectangle. And I want to have so much area inside of there. Okay, let's go ahead and write the coordinates of the points here. So we have x comma y, just a random point. Okay, how about this point? So much to the right, so it's going to be x comma 0. Remember, an x-intercept has 0 for y. A y-intercept has 0 for x, so that's 0 comma y. And the origin is 0 comma 0. So we've drawn a random rectangle. That point can be as high as I want or as low as I want, but it's got to be somewhere on that graph. And as I move the point, the shape of the rectangle changes. Okay, so what we're going to do here is express the area of the rectangle as a function of x. So function notation, okay, it's usually f of x, but they want a. So we're going to call this area a of x. Okay, so it's kind of like writing a y. There's your function notation. And how do you find the area of a rectangle? Well, I need to take the base times the height, or the length times the width, whatever you want to call these. So how wide is it down there? It's x units. And then how tall is it? Y units. And these are random because it could be as tall as I want. So the area of this rectangle is x times y. Except, wait a minute, it's set as a function of x. That means the only letter they want is x. The only variable allowed is x. Okay, so we're going to have to take y out of there. So it's going to be x times something else. Is there anything else I could call y? I'm not allowed to call it y. And I know that it's from this graph right here. I know the point has to stay on the graph. Take a look up here. Take a look up here. Right there. That is what y could be equal to. If I rearrange this, it's negative x squared plus 25. It's a parabola facing down up 25 units. So that value can go in for y. So I'm going to go ahead and I think I'll just put the original one in there. 25 minus x squared. Replacing y with his equation. Now I have a function in terms of x. What is the domain? All right, this one's going to be a little different. So what we're going to do here is for this rectangle to exist, you want the base to be more than nothing. You want the base to exist. If the base was 0, it wouldn't be a rectangle. Similarly, you want the height to be more than nothing. You have to have a height more than 0, otherwise it won't be a rectangle. And so if you look at your equation right here, it tells you the base. So here's the base, and right here is the height. Base times height. So I'm going to take x, because that's the base, and I'm going to say x has to be more than 0. Done. Now I'm going to take the height, which says 25 minus x squared, and that has to be more than 0. But this is a mathematical problem. I'm going to have to solve that inequality. I'm not allowed to move over and square root it. Okay, the first thing we're going to do is factor. Okay, and how do you solve a quadratic inequality? We have to draw a number line. So let's go ahead and draw the number line here with -5, +5. Are they going to be open bubbles or closed bubbles? It says greater, so I'm not going to use those. And I always like to start with 0. Is 25 minus 0 positive? And the answer is yes. So this is the section of good answers. Now you have to make sure that the base exists and the height exists. So we're going to put two of these answers together to state the overall domain. He says be more than 0. And he says be between -5 and 5. So I think x is going to be between 0 and 5. And that's the domain of my area equation. That's not the domain of this parabola graph. This is the domain for the rectangle. Okay, so now we're going to start drawing a graph and doing some calculations for the area, So this is area of the rectangle. They want me to draw a graph for the area of the rectangle. And it doesn't make sense to show any negative numbers. So what we're going to do here is graph the positive x-axis and the positive, oh wait, where's my area equation? There's no y. There's x's and there's a of x. So this is the a of x axis. X and a of x. Now it says label the axes. Okay, I'm going to give points for all these things. So what does the a of x axis represent? The a of x tells you right here represents area of the rectangle. And what does x represent? I see x in the equation, and that x came from this picture, and x represents the base of the rectangle. Base of the rectangle. Okay, so your a of x, that's usually pretty obvious, represents area. So we're looking at this equation right here, the area equation. Now let's take a look at the domain. Since the domain was between 0 and 5, it makes sense if my x-axis goes from 0, 1, 2, 3, 4, and 5. Okay, at this point, everything should be labeled. Your x-axis is there. Now it's time to use our technology. We're going to graph this equation right here with our calculator. So let's go ahead and get those out for this section of the chapter. It's been a while. We're going to go to y equals and clear out everything that might be in there from last chapter. Okay, and we're going to, and even x, we're going to type in this area equation. And I'm just going to leave it like that. I'm not going to distribute and mess it up, because what if I make a mistake? So it's x, and then it's 25 minus x squared. Okay, and I'm going to go directly to the window. I don't need to see negative x's, because it doesn't make sense to have a negative base. I already know what the x window needs to be. It needs to be between 0 and 5. Now how about the y scale? It does not make sense for the area to be negative. So the y minimum is going to be 0. Now the maximum you're going to have to figure out. But everything else here you should know. The area needs to go up so high. I'm just going to start by guessing 20. Okay, and let me see if this is high enough. Oh, it's not high enough. Maybe I'll go up twice as much. Let's go up to 40. So the y max, you're going to have to play with a little bit. Some people go really big and bring it down. Some people inch up slowly. Some people go in huge chunks just to get there quickly. If I go as high as 40, oh, almost. Okay, maybe I'll try 50. Since I'm going so high, I'm going to change the scale to take marks of 5. That's better. 5, 10, 15, 20, all the way to 50. There it is. So I know that the graph went from 0 to 5. And on your graph up here, you need to tell me how high you went. And I went as high as 50. 10, 20, 30, 40, 50. And then the picture looked something like this. From 0 to 5. Okay? So here's a really great graph representing the area. For what value of x is the area the largest? So how are we going to find the largest x? The largest x. So in our calculator, we're going to have to use the maximum feature. So remember where that is? Second calculate. And the maximum 4. Now, did you guys know, instead of click, 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 you can just type. I'm going to type, I'll type 1 as my left bound, and I'll type 4 as my right bound, and I think it's between 1 and 4. Then you have to click at least 1 over to get in between your two bounds, and the maximum value to 2 decimal places is 2.89, comma 48.11. Okay, now don't touch anything on your calculator. Leave that right there. Just move your calculator over to the side, and let's talk about what this means. This is the x value, this is the y value. And everyone knows how to use their calculator to find it. The question is, what does it mean? 2.89 is the x. Do you want to know what x stands for? Well, look at the label you put on your x-axis. X value represents base of rectangle. And what does this y value represent? The area of the rectangle. So what value of x? X is approximately 2.89. And I don't think we have any units, so I'll just say units. What is the largest area? The largest area is approximately, that's the y value, 48.11 units squared. Okay, and now it's time to talk about dimensions of the rectangle. Okay, dimensions are the base and the height. The base by the height. If you had a triangle, it would also be base and height. So I have to say the base and I have to say the height. So let's go look at our rectangle up here. In fact, the best place to look for dimensions is the equation. Here's the base, here's the height. That's how you do area. Base times height. So the base is the x, and I already found out the x, 2.89. So the base is 2.89 units. Now the height, you're going to have to calculate. Okay? So if you look at your equation, no matter what type of shape you have, this is the easiest thing to do. This is the height, 25 minus x squared, and I'm going to show you a trick with the calculator. If you still have maximum and that cursor up there, what I want you to do is second quit. Don't move the cursor, just quit. Now anytime you type in x, it grabs the x from your graph, all those decimals plus more. So what I want to do is I want to figure out 25 minus x squared. I want to take all those decimals even more, take the entire value of x, I want to calculate with it, but I want the calculator to grab that number for me, and the answer is 16.67. And that's units. Okay, we're going to do this for a couple of days, getting the hang of things. The biggest thing is labeling your axes before you even pick up the calculator so that you know what they represent, and it makes everything a lot easier. Okay, here's another one. We have a right triangle on the vertex of a graph. So what shape is this graph? Parabola opening, down, but it's 9 units up. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, this is kind of fun. Let's do the growth pattern for a parabola. Over 1, down, 1. Over 1, down, 3. Over 1 down, 5. So here's the parabola. Okay, all right, that's nice, little parabola, but we're going to put a shape in there. And the shape we're going to put is a right triangle. One of the vertices is on the graph, anywhere on this graph. So let's just pick like the middle of a box somewhere, be very vague. And that point is x, comma, y. Another one's on the origin, okay? And the third one is on the positive x-axis. Positive x-axis right there at x, comma, 0. So here is the triangle, a right triangle. There it is. Okay, got a lovely picture. Express the area of the triangle as a function of x. So remember how this looks, a of x equals? How do you find the area of a triangle? It's 1/2 base. Let's see, how long is the base? The base is x, 1/2 times x times the height, and the height is y. So it's 1/2 times x times y. Oh, but wait a minute. It says as a function of x. We're not allowed to have any y's. So a of x equals 1/2 x times, instead of y, what can I put there? How about this, the equation for y? Parentheses, negative x squared plus 9. Let's just stop and label this here, because this is going to help us later. This represents 1/2. X represents base, and this represents height. Okay, we're going to need that throughout this whole page. So if you understand how you made the equation, that'll help you with everything else. What's the domain? To have a domain exist, for this triangle to be in existence, the base has to be more than nothing, and the height has to be more than nothing. Now I know the area formula has 1/2, but that's just a half. 1/2 is more than nothing, so you don't worry about that at all. Let's just say x is greater than 0, done. And this height, I think what I'm going to do is rearrange and say 9 minus x squared is greater than 0. Now every problem that you work with, you're going to realize here has the same trick. This is always a quadratic inequality. I always want to see you factoring greater than 0. I always want to see a number line, -3, +3. Now let's go ahead and test the sections. Since it says greater, these are open bubbles, and let's try 0. 9 minus 0, yes, it's 9, that works. And so let's put our two dimensions together. I want the base to exist, I want the height to exist, so x is going to be between 0 and 3. Okay? Let's graph a of x and label the x's. Okay, so remember, we're always going to draw quadrant 1. We don't want to have any negative areas. The axes are x and, well, not y. Let's look at here's our area equation. X's and a of x. A of x is usually the easier one. What does that represent? Area of, this time it's area of triangle. And what does x represent? There's the x. There's the x, and x represented base of triangle. Look at your picture. You put x there, that's what x is. Base of triangle. Don't just say base, let's be a little more specific. Now we already have the domain. The domain goes from 0 to 3. So 0, 1, 2, and 3. Now in terms of the y value, we're going to have to use our calculator to figure that out. So let's go get our calculator, and we're going to clear out that y, and we're going to put our new equation in. Maybe I use that fancy fraction button. 1/2 x parentheses negative x squared plus 9. Okay, and go to your window. Right, I don't want to see you guys drawing all 4 quadrants. Get a really nice view of quadrant 1. The domain goes from 0 to 3, so that you should know. And then the y minimum is 0 to, well, I have to go figure it out. I guess we could try 50. Oh, that's way too high. Okay, 50, 25. I'm going to try like 0 to to 10. Let's just try the normal 0 to 10. Beautiful. It fits. 10 is certainly high enough. Now, if you said 20 or 30, that's not wrong. You have to say, well, higher than that. Okay, so at least, I don't know, was that like 6 or something? I went up to 10. You have to find that number from your calculator. The graph looks like this, has 0 area, gets bigger, comes back down, and oops, has 0 area if it gets to 3. Okay. The next thing I'm going to do is second calculate a maximum. I'm going to guess 0.5 as the left. I'll guess 2.5 as the right. Yep, definitely between there. Click a little bit to the left and hit enter. Now don't touch any buttons. Leave your calculator just like that. The maximum is 1.73, comma, 5.19. Let's see, I want 2 decimals, but 6 is big, so 19 needs to turn into 20. Put the 0 so I know you rounded it to 2 places. Okay, and now it's just time to answer some questions. What value of x is the largest area? What value of x? The largest area value of x is 1.73. Oh, I think these are units. Just units. What is the largest area? So if you're not sure what these numbers mean, the x value goes there, and the y value stands for that. So the area, the largest area that this triangle can get, I can draw different shaped triangles in there, but the largest area I could get would be 5.20 units squared. Okay, and now comes the question that everyone has a little trouble with. So let's make sure we go and look at our work here. Dimensions of a triangle. Dimensions are base and height. So those are the 2 dimensions that we need to say, base and height. And the best place to go figure this out is looking in the equation. The base was x. So x is 1.73 units. That's our x, 1.73 units. And height is the trickier one. The best place to figure out height is if we go right up here to the equation. This expression right there represented height. So if you have your calculator and you didn't move the cursor, you just second quit. You can clear that out. It's okay. Anytime you type in x, it's going to grab the x from the maximum. If you want to check, you can just hit x. Yep, that's the x value I want. But I want to calculate negative x squared plus 9. So the height is 6.00 units. 6.00 units. Okay, let's come to class tomorrow and practice some word problems together. Thanks.